All right, so in this video, we're just going to go over just a basic intro to functions. So we're just going to talk a little bit about what functions are, some properties of functions, and just the basics on how to graph a function. All right, so first let's start by talking a little bit about properties of functions. And so the purpose of a function is to provide some output for a given input. All right, so for example, if you put in a 2 and a 5 comes out, put in a 3 and a 7 comes out, and so on, that's a function. So you input a value and you're going to get another value out. And these are represented by an equation. With the variables x and y. So it's going to be an equation such that y equals something where this something contains some sort of x. So this side of the equation, y is going to equal some sort of polynomial or monomial, and x is going to be in there. So if you're given some inputs and outputs, so your input is going to be x and your output is going to be y. Say 0, 1, 2, 3, and this is going to be 0, 2, 4, 6. All right, so in this case, your input or your x values is going to be called your domain of your function, and then your y values is going to be your range of your function. Now, we can also represent this relation on a graph. So you can go ahead and just graph these. And what you're going to do is you're going to create ordered pairs from all of these inputs and outputs. So for example, we're going to have a point 0, 0, and then 1, 2, and then we're going to have 2, 4, and then 3, 6. So 0, 0's here at the origin, 1, 2, 2, 4, 3, 6. All right, and that's going to be the graphing of this particular function or relation. Now, another thing you can also do is draw a mapping diagram. So this is the graph, and then we can also do a mapping diagram where you just have all your inputs on one side and then your outputs on the other. So we write all of our inputs below, so 0, 1, 2, 3, and then our output 0, 2, 4, 6, and then you draw arrows from your input to the output that it corresponds to. So for this case, they're all just going to be straight across. However, if we had something like this, like that. We're going to go ahead and do our mapping diagram. So we're going to put these in numerical order. So 0, 2, 3, 4. These in numerical order. So 1, 2, 4, 6. Now 0 corresponds with 4. So we're going to draw an arrow from 0 to 4. 2 goes with 6. 3 goes with 2. And 4 goes with 1. So that would be our mapping diagram for this instance. And again, you could also graph this as well. Now, if you want to determine if this is actually a function or just a relation, then you have to check to make sure that there's only one output for every input. So exactly one output for every input. So for this example up here, if we look at that, for every input, we only have one arrow coming out of it, so therefore this is a function. However, if we had an additional value over here where we had, let's say 0 and 5, then we'd have to add 5 to our output list, and 0 would also be going to 5. So now for our input, we have one of our inputs where there's 2 arrows going to different places, so therefore this would be not a function. All right, so that's how you can check with a mapping diagram. However, if you wanted to check for a function from a graph, you're going to use something called the vertical line test. So what you're going to do is you're just going to take this vertical line and move it all the way across your graph. And as long as this vertical line is only touching one point at a time, then you have a function. However, if it ever crosses more than one point, then it is not a function. So for example, if we were to graph these, let's do that right here. So 0, 1, 2, 3, 4, 3, 1, 2, 3, 2, 4, 1, 2, 5, 6, and 0, 5. So we're going to take our vertical line and we're going to move it across this way and make sure that only one point is touching that vertical line at a time. However, when we hit here, we're crossing this point and this point, so therefore it's not a function. However, if we got rid of this last point here, so 0, 5 we're going to get rid of. All right. Then we'd have our vertical line that comes through here. It's only touching one point. Comes through here, only touching one point. Here, only touching one point. Here, only touching one point. So therefore, that would be a function. All right. So it's as simple as that. All right, so now let's go ahead and take a look at some functions. So let's learn about solutions to functions. So let's say we have the function y equals 3x plus 1. Now we've got some ordered pair, let's say 2, 7. All right, and we want to know if this is a solution to this function. Now, what you do is, if we remembered, ordered pairs are x, y, so you can go ahead and plug 2 in for x in your function equation and 7 in for y. All right, so let's go ahead and do that. So y equals 7, so we're gonna have 7 equals 3 times x, which is 2, plus 1. So 7 equals 6 plus 1, 7 equals 7. Now, because this statement right here is true, the ordered pair is a function, or is a solution to the function. Therefore, 2, 7 is a solution. However, if we wanted to check, let's say, 1, 6. So again, we're going to plug 1 in for x, 6 in for y. All right? So we're going to go 6 equals 3 times 1 plus 1. 6 equals 4 plus 1. 6 equals 5. This statement right here is false, right? Because 6 does not equal 5. So therefore, 1, 6 is not a solution to that function. All right? Now, if we wanted to find solutions to our function, we can also do that. All right, so let's say we've got the function y equals 2x minus 2. All right? And we've got the ordered pair, let's say 3y. And we want to find a solution to this equation in this form, so where x equals 3. So again, this is x, y, so we're going to plug 3 in for x and then y in for y. All right, so y equals 2 times 3 minus 2. Y equals 6 minus 2, so y equals 4. So a solution, so just one of the many solutions to this function, equals 3, 4. All right, and then that also works if you're given, let's say, x1. You're just going to plug x in for x and then 1 in for y. So let's see, 1 equals 2x minus 2. And then you just solve for x like you've solved in other equations before. So add 2 to both sides. 3 equals 2x. Divide both sides by 2. And you'll get that 3/2 equals x. So another solution is going to be 3/2, 1. All right? So what do these solutions actually mean? So if you were to graph a function, it means that the line from that function on the graph goes through these points here. So let's go ahead and look at the function y equals x plus 1. Let's keep it simple. What you're going to want to do is you're going to create a table of x and y's, so inputs and outputs, and let's just go with -2, -1, 0, 1, 2. All right, and if we use all of these inputs and get all of these outputs, then we can plot those points, connect them with a line, and then that is our graph of this function. All right, so that's what all of these solutions mean, is that they're points on a line in a graph of the function. So we're going to go ahead and plug x equals -2, so y equals -2 plus 1, y equals -1. And for x equals -1, y equals -1 plus 1, so y equals 0. For x equals 0, y equals 1. For x equals 1, y equals 1 plus 1, y equals 2. And for x equals 2, y equals 2 plus 1, y equals 3. All right, so then we're just going to take these and graph them. All right, so we've got -2, -1, -1, 0, 0, 1, 1, 2, and 2, 3. So we plot those, we connect them with our straight line, and that is the graph of our function. And again, every solution is on this line somewhere. All right, so every solution that you could find using this method that we learned up here is going to be a point on this line here. So that's just a basic intro to functions. Watch the next video if you want to know more.